welcome to our first climate change lecture. So our topic for this week, it's based on chapter 1, the introduction to the atmosphere. And first, I want to talk about the weather in the United States. So, of course, we live in California and we are familiar with the weather here in Cali and elsewhere in the Midwest and the East Coast. Um, so, severe weather events occur here in the United States, such as tornadoes, flash floods, and intense thunderstorms, and hurricanes and blizzards. And these severe weather events are collectively becoming more frequent and more damaging in the United States than in any other nation. We've seen recently the flash floods that occurred in Texas due to the flooding of the Guadalupe River and the disastrous impacts it had on that community. So, again, we have to be mindful of what creates these severe weather events and the processes for that. So, this climate change course will help you to better understand the processes and the mechanisms of storms, of hurricanes, and other severe weather events. Also, I do want you to keep in mind the location of the United States. The United States, it's located between two special lines of latitude. The first one is the Arctic Circle, and the other one is the Tropic of Cancer. So here we have our latitude lines, and this one we can't see clearly, but we see here, if I can get my little pen. So we could see 40 degrees north. So this is 50 degrees north. And this is 30 degrees north. So again, the United States it's in between the Arctic Circle roughly and the Tropic of Cancer. So this is found in the mid-latitude zones, on the mid-latitude zone. So the position of the United States is what allows all these severe weather events to occur, especially when we have air masses, cold air masses coming from the poles, and then warmer air masses coming from the tropics. So here we have a satellite image which shows Hurricane Sandy, and this was called Superstorm Sandy in the media, battering the U.S. East Coast on October 30th, 2012. So this view of the storm is looking south from Canada, and Florida is near the top of the image, like we see here, the Florida Peninsula. Other severe weather events that we experience here in California are heat waves. We just recently got out of a heat wave in the past 2 weeks, but here in this slide we're looking at the 2024 heat wave of last year, and it states here that on September 7th, temperatures shattered 5 records in LA and Orange counties, which were set in the summer of 2020. So last year in 2024, the LAX had a temperature record of 102 degrees, and that broke the 2020 record of 99 degrees. So learning about heat waves, it is crucial because they are increasingly frequent and intense due to climate change, posing significant threats to human health, infrastructure, and the environment. So this slide, we're looking at basic terminology such as meteorology, weather and climate. Meteorology, it's the scientific study of the atmosphere and atmospheric phenomenon that we usually refer to as weather. So this course is based on meteorology. And what is the difference between weather and climate? Well, weather refers to the state of the atmosphere at any given time and place. So weather, it is constantly changing, sometimes from hour to hour and at other times from day to day. For example, the weather today is or was 90 degrees, but we know that weather is always shifting. So in the morning, it will have a cooler temperature around 70 degrees or 60 degrees, and then the weather will get warmer by the afternoon and then cool back down again in the evening time. So that is what is meant by weather. So it is only at a given time and place. And climate, specifically in the context of weather patterns, it is typically based on 30-year averages. So it's a generalized weather variation for a given place. It's important to realize that climate data cannot predict the weather. Although the place may usually be warm, sunny, and dry during the time of your planned vacation, you may in fact experience cool, overcast, and rainy weather. And that example can go here for LA. Southern California, we have, well, specifically for Los Angeles, we have a Mediterranean climate, so warm, dry summers and wet winters. And so if you were visiting LA for the first time, you would expect a warm, sunny day, dry day, but there may have been a thunderstorm, and we've had frequent thunderstorms throughout our summer this year. So that is our weather. There is a saying, climate is what you expect, but weather is what you get. Here we have a typical weather map for a day in late December. So this is a typical weather map we see on the news channels. So here we have the colored bands which show predicted high temperatures for the day. And the colored bands are the coldest temperatures are at -10 degrees, all the way to the hottest temperature in this map, 110 degrees. And then we have a legend of the type of weather that is occurring in these locations, whether it's rainy or a dry, sunny day. And for your quiz, you will answer 3 questions about this weather map. And first, it'll ask you about our pressure system. So on this map, we have 2 pressure systems that are symbolized as a big blue H here, representing high pressure, and the red owl representing low pressure. So we tend to see with the high pressure system, if you look at the legend, sunny skies, fair weather. And with the low pressure, you could see precipitation, whether it's thunderstorms and rain, heavy rain. Also, keep in mind that this map, it's an isotherm map showing us equal lines of temperature at all these locations. So again, every point on this line or the location has the temperature of -0 degrees Fahrenheit. Okay, so, and when it's between 2 isotherm lines, it is given a range. So here with the blue band, we have from -0 to 0 degrees, and so you have a range between there. So that's how you will read an isotherm map. And weather and climate are expressed in the same elements. So air temperature, air humidity, type and amount of clouds, type and amount of precipitation, air pressure, speed, and direction of wind. And it's important to note that although we will be studying these elements separately, they are very much interrelated. So a change in one of the elements often produces changes in the others. For example, an increase in humidity, meaning that there's a lot of water vapor in the air, can decrease air pressure because a water molecule weighs lighter than the surrounding air of nitrogen and oxygen because of the molecular weight of the water vapor molecule. Here we're looking at atmospheric hazards. So this image shows us the impacts of severe weather, and natural hazards are a part of living on Earth. We experience thunderstorms, hurricanes, tornadoes, blizzards, and a single tornado outbreak or hurricane can cause billions of dollars in property damage, much human suffering, and many deaths. This image, like I just mentioned earlier, shows us the impacts of that. And also, non storm related severe weather events are cold waves and heat waves. So, again, heat waves, or the heat is the number one killer worldwide. So, we have to be mindful of our severe weather events that we experience here on Earth. So, here between 2004 and 2016, the United States experienced 102 weather related disasters in which overall damages and costs reached or exceeded 1 billion. Here we see the blue bar graph, and it represents the number of events, severe weather events, and then the red bar graph represents the damage amounts in billions of dollars. So here on the y-axis, the damage amounts in billions of dollars, and here on this side of the y-axis, it's a number of events. So we tend to see here with the pattern, fewer severe weather events has a higher amount of billions of dollars in damage, like we could see here, close to 200 billion in 2005. So here we're looking at observation and measurements of the basic parts of the scientific inquiry, and we're looking at, in this image, automated observing systems, and these are designed to measure several of the weather elements that we just reviewed. So cloud coverage, temperature, and dew point measurements. They can determine wind speed and direction, and even record present weather, such as whether if it's raining or snowing.